it's Keith here, and this is episode 13 of the ChibiAkumas series of my Z80 programming tutorials. Now, we looked over the last two episodes at how the player driver worked, which draws the player onto the screen, reads the key input and handles the firing. There is one other important part of the player procedure though, and that's the drawing of the scores onto the screen. And this is done last because we need the scores and the sprites to be above everything else on the screen. And while the CPC Plus draws the sprites at the top automatically, on the regular CPC and the other systems, the drawing order is important. So this is a separate routine, and let's take a look at it today. So here's the start of the player UI, which draws the top level of the interface, which is the scores and the sprites for the lives and the smart bombs. So the first thing we've got here is some routines that handle the CPC Plus. And what these do is they will draw the sprites into the buffer. Now you see I'm actually cheating on the CPC Plus. I'm using 6 sprites for the lives and the smart bombs, but I'm doubling them up on the screen. And you see the sprite definitions are loaded into 2 buffers, and one of those buffers is loaded into the plus sprites at the top half of the screen, and the other is loaded into those plus sprites at the bottom half of the screen. This has the effect of doubling the sprites as they appear on the screen. You'll notice that the sprites for the hearts and the smart bombs for Chibico are in the opposite position to the Bochan character. That's because I'm repositioning the sprites as the screen draws. So we load into a buffer, but that's kind of by the by. The important thing is we need to be able to draw those sprites easily and define them based on the life counter and the smart bomb counter, and for that we use this if a non-zero routine here. What this does is it walks through the buffer, decreasing a as it goes, and when a gets to 0, it stops setting the buffer definitions to 9 and starts setting them to 0. Now 9 is a scaling option for the CPC Plus sprites, and what it means is mode 1 size. A 0 means hide the sprite, you see. So we're cycling through that and defining those based on either the lives or the smart bombs. So this routine is shared and it's run twice here. But of course we need a similar routine for the non-CPC Plus, and that's what this is here. So this is the draw icon loop routine, and it uses show sprite direct, which is similar to show sprite except for it can't do clipping and things, so the sprites have to be completely on the screen. So here we're cycling through the icons and we're showing the sprite the correct number of times here. And when we get to 0, we just leave, as you can see here. Now here's some continuing routines. These handle if one of the players is dead, and then we drop into the dead routine here. So here's the draw UI. This is actually what we run from the level loop, and we run this pretty much last because this has to be at the top of the drawing stack, except maybe for the warning messages for the boss battles. Now the first thing that appears at the top of this draw UI is probably quite surprising. It's actually relating to the drones. Well, why is that? Well, we need to do some calculation work for the drones, but we could only do it after the player code had been completely executed, and because the last command of the second player would return back to the level loop, it seemed more sensible to put it here. So what are we doing here? Well, what we're doing is we are flipping the 2 CPC Plus sprites for the drones. You see the 2 sprites are 2 stages of animation, and rather than updating all 256 bytes of the sprite data for the drone, we just flip their positions, and that's very quick, whereas setting all that data will be very slow. Of course, we do need to check how many players are alive and how many drones are present between them, and that it does change how we cope with those drones. Now, when we get to here, we're actually ready to start processing the player settings, and what we need to do is we need to work out if the players are alive or not. And so if we are running this routine, then player 1 is alive. If we're running this routine, then player 2 is alive, and we're checking these player parameters here accordingly. We're checking them directly because it's slightly faster, although we do have to load UI with the correct player data here. Now when we get to here, we're done with the player drawing, and we can show the player continues if necessary here. This is the routine that will show the continues to the screen. What we do is we have to set the position for the continue message, and we have to show the credit message depending on the player. It will either appear on the far left or the far right where the score should be. We show the continue count as well. There is a special mode where each player has 2 separate continue counts. There is another mode where they both share it, which is the default mode, which is why we've got this slash here. This is self-modified though, so that if that isn't in place, we don't use it. And then when we get to here, we're showing how many credits are left in the correct position, which varies depending on the screen size here. And then we are setting the font correctly, and then we're showing the continue message here, just using this command here. And you can see the continue messages here. They're slightly different. The Japanese version needed it defining in a different way, but there's generally no difference. Now this is the common UI drawing routine. This handles all the generic things like the life icons, the smart bomb icons and the score. So the first thing we need to do is we need to define the move size and the XPOS. Now you'll notice these are different depending on the player, but the code that actually execute them is kind of backwards in this example, so we'll see it later. But we're loading in the positions for the sprites and also the space between them. You see the sprites on the left hand side are moving left to right and the sprites on the right hand side are moving right to left. So we not only have to move the position but the actual direction we're moving in, and we're just using self-modifying code here, as I often do. Here we're loading in the sprite positions. On most systems we just need the memory banks, but on the NSX we need the Y position because that's how the sprites work on that. If we're using the CPC plus, we also need to define the plus icon memory addresses here, and we need to draw the plus sprites if we are on a plus system. You'll notice something quite odd here. We're using this plus sprite definition here on the MSX as well. That's a bit misleading probably, but I did need some extra data for the memory address of the buffer for the extra sprites on the MSX. I used the plus sprites definition even though it's a little bit misleading there. Anyway, we load in those into the X offset of the sprite and also the bank address of the sprite here. We're going to use show sprite direct, so we do need to define this X offset directly here. Now here we're defining the sprite number we're going to show, and we load that in here, and then we load the Y position in here, and it's 8 down because we need to make space for the score. And then we start using this draw icon loop here, which will draw all of the sprites depending on the parameter we've loaded in. And you can see we've loaded in the life sprites here into B because this routine uses B. And then we carry on down here and we do the same, this time for the smart bombs. Of course, these are the non-plus versions here. Now here's the player 1 draw UI. As I say, this is kind of misleading because really this probably should have been up there. So we're loading in the icon size here for the spacing, and we are loading in the address of the plus sprites, and we're loading in the parameters for the drawing of the score, which we will also see in just a moment. Now the reason that this code is in the wrong place is so we can use this jump relative here at the bottom, because it will save 1 byte rather than a jump here. So it's in the wrong position for us to read it, but it is in the right position for the saving of memory. Now you can see here, we're going to see in just a moment the score drawing routine. We'll have a look at that in just a moment, but basically we need to set the score position, and we also need to set the position of the burst points, which will appear below the lives on the left hand side of the screen. Here's the player 2 version. You'll notice these were positive here and these are negative here, and that's because the icons appear on the right hand side and move leftwards. And you'll see also we've got these alternate positions for the score on the burst pos here. Again, they're flipped around. Now this plus as well part, this is where the execution will return to once we've drawn the CPC plus sprites. That's why it's called plus as well. It's used by the regular and plus machines, you see. So this is where we're actually going to start handling the score. So how do we handle the score? Well, we load the score in from the memory address we've had passed to us, and what we do is we first have to define our bitmap font here to get it ready. We're going to draw backwards because we start from the right hand side of the array. Now one thing I should point out here, it's quite possible that my score routine isn't very advanced. There's a good reason for that, because this is the first time I'd used binary coded decimal. I mean, honestly, it was the first time I'd done everything, because ChibiAkumas was my first assembly game, but some of the code here, I'm suspicious, is pretty crude, but it does work, so I leave it alone. The data for the score does have to be byte aligned. It's using the address of the byte as the counter, so it's important we align the 8 bytes so that the last byte will be on a 0. And then what we do is we're drawing the sprites to screen here using this char sprite direct. This will show the score to the screen, and then we are running the update score routine. Well, what does the update score routine do? Well, if you've played the game, you'll know that the scores go up kind of like a pinball machine. They kind of roll up. Honestly, part of this was I simply didn't know how to do it any other way, but I did actually like the effect as well. So it was just the way it worked. Now, the score to add to the current player's score is held in a single byte. So if the player was collecting score really, really fast, maybe they could fill out the score single byte and it would roll over. So to avoid that, I check if it's over 30. And if it is, I run this repeatedly just to reduce the score back to a sane level. So we're going to see this update score routine in just a moment. But when we get to here, we're showing the burst power. The burst power is the ability to hold down both fire buttons and fire in all directions. It's a single byte from 0 to 255, and it's shown just below the lives on the left hand side or the right hand side of the screen, depending on the player. Now you'll see here there's a self-modifying command called cheat mode. Well, what's this? Well, there's a cheat mode in the game. I think you press F6 or vice versa on the credit screen, and that will show the tools for cheating bastards, as it's called. What this is it allows you to cheat, it allows you to have infinite power, it also allows you to jump to any level within the game, and this is for me to test the game essentially. So I wouldn't often need to jump to the last boss battle and be able to play it. You can't play it without any power-ups, so there's a mode that gives you all the power-ups, and that's what you're looking at here. So what we're doing here is we're hard coding in the power-ups to player 1. It's very crude, I really couldn't spare the memory. There's no way of giving full power-ups to player 2. As I say, it was simply for testing the game, just to be able to jump to a certain level if that level was having trouble. So here's the update score routine. So what this does is we are now reading in the score that is waiting to be added. If there isn't any, then we don't do anything, of course. And then what we're going to do is we're going to load in the memory address of the score, and we are going to cycle through it. We're going to add a single unit of score from the waiting score to that byte. If the byte goes over 10, it's unpacked binary to go to decimal, so each byte goes from 0 to 9. If it goes over 10, then we move to the next byte, and we set this one to 0. Now at this point we do want to check if the score's rolled over to 100. The reason for that is we give burst power at 100, and that's what we're doing here. This is the burst power, this is how we get score. Of course, if we wanted to make it 1000, we could change that to 4, and if we wanted to make it 10, we could change it to 2, but that would be a bit silly. So that's what we're doing here, and then when we get to here, we've finished updating, and we just roll back to the next digit. So there you go. That's fairly complex, obviously, but unfortunately with a game of this complexity, it's unavoidable. I hope this has given you some brief introduction to how those routines work. They were changed slightly for the Tragical Chase game, but there wasn't anything major really in there. It was just some slight tweaks to the way that the code would work because the second player was removed and there was a special level end. But as I say, basically speaking, the code to a great extent hasn't changed that much since the original episode 1 even, and the episode 2 and the remake. The only changes that were made were a few slight tweaks and the extra MSX and Spectrum code. So the game hasn't changed too much, and hopefully it's now pretty reliable. Now, if you were wanting to make changes to this, maybe change the firing routines, you could of course do that. You would have to really consider the way the CPC Plus sprites were working. You couldn't do something like have 4 lives because that's a hard limitation to the number of sprites you can show on the screen. But I mean, one thing I would suggest if you want to make your own game based on this is just turn the CPC Plus sprites off. The game's perfectly playable without CPC Plus sprites, and you'll be making your job a lot easier that way. Anyway, I hope you've enjoyed this. We're going to keep looking at the ChibiAkumas game. We're going to look at some other modules and finally have a look at the level code itself. So anyway, thanks for watching today, and goodbye.